Hi guys, welcome to our discussion. So we are going to look at a second technique that is going to be applied in factorization of polynomials. And as we said that this particular technique is applied in combination with the first technique that we have said, which was factorizing out the greatest common factor. And we have done this one using a specific example. So under the concept of grouping, we are going to see that polynomials with more terms, like 4 terms, can be factorized by grouping them into 2 pairs and factoring out the GCF, which is the greatest common factor. Now in this case, I'm going to give a specific example for this particular application, whereby we're going to have a polynomial, example of a polynomial which is given as x to the power 3 plus x squared plus 3x and then plus 3. So in this case, as I've said, for grouping technique, we're going to have polynomials with their terms like this one, which is having 4 terms, which is going to be factored by grouping that one into 2 pairs and factoring out the greatest common factor. So if I try to group this one in 2 pairs, I'm going to have this first set given as such and the second one given as such. So therefore, next I'm going to look for the greatest common factor in those 2 pairs of groupings, and then I'm going to find out this pair of grouping, and I'm going to find out. Now for the first one, I'm going to find the GCF being x squared, and then it's going to factor this one by x plus 1. And then for the second one, I'm going to factor out 3 and give it as x plus 1. So this is one of the technique of grouping, which is applying the combination of identifying, or rather grouping this specific polynomial into 2 factors, or rather into 2 pairs, and then trying to factor out using the greatest common factor. And therefore I'll have this one as 2x plus 3 and x plus 1 as the respective terms or expressions which have been multiplied to obtain this starting polynomial. So in this case, we're also going to see that there's a different way in which we can be able to obtain this, of course, terms by trying to do the concept of factoring. Apart from grouping, I'm going also to use a different expression to try and figure out how we can be able to do another way of factoring. And this is going to apply, or rather use the expression of ax squared plus bx plus c. We're going to come across this expression, but for now I'm just going to reserve it for this specific discussion, whereby we're going to see that a, b and c forms what we call real numbers. So this basically refers to the coefficients for a and b, and then the constant which is being given as c. So from this, we are going to see that to find the factors of this specific polynomial, we're going to use this expression whereby we're going to find the factors of the product. So we're going to find the factors of the product AC, whose sum is b. So I'm going to elaborate on that using that specific expression. So in this case, we're going to look at this specific expression and compare it with the polynomial that we're working with, whereby we're going to see that the product of AC should give us a number whose factors of its sums is going to be b. Now that one is going to be understandable using an example. So suppose I have a polynomial like 2x squared plus 5x plus 2. Now this is analogous to this specific expression that has got a degree for 2, 1, and then there's a constant there for c. So I'm just going to do a comparison of this. So therefore we're going to apply this rule whereby we have recognized that a, b and c are constants, are real numbers, and then therefore we're going to find the product of AC, which are the coefficients for 2 and 2. So therefore our AC is going to be 4 and then therefore we're going to look for factors of 4, which are factors of 4, which is a product whose sum is b. So we are expecting a sum of 5, which is resulting from the factors of this specific number. So therefore we're going to see that that is going to entail 4 plus 1, which is going to give us 5. So therefore if we are trying to factor out this, or rather give this specific second term as factors of this, therefore it's going to be 4x plus x, which is going to give us 5. So therefore we're going to just do a substitution for that and try to see how it works. So it's going to be, so this expression is going to be written as 2x squared plus 4x plus x plus 2, whereby the second part, as I said, implies that 5. So from that we are going to just do a grouping of those specific terms as we did for our previous one, and try to find the GCD, GCF in this particular case. So I'm going to do this like this, grouping. So therefore I factor out the greatest common factor, which is 2x, into x plus 2, and then for the second one, this is just basically going to be 1, x plus 2. So implying the factors for this, just bring them here. So the factors for this are going to be 2x plus 1 into x plus 2 as the factors of this specific polynomial. So in this case, this method of also finding factors is known as factorization. I mean factoring, apart from the one that we have described for grouping of those specific polynomials. So next we're going to look at our last two sets of techniques that we can use to do this factorization. And that one will consist of the technique of using special products that we had already mentioned, and then by trying to do what we call a substitution. So catch us in our next video as we discuss on the last 2 bits of this factorization of our polynomials. And of course, as I said, kindly go to YouTube and subscribe to our channel, engage us so that we can be able to have more of such discussions and assist each other. So that is it for now. Bye guys, God bless you.